So, a few terms and some new concepts, but they're huge. So if you need to watch this clip like a couple of times before you get it, I recommend that you do. Well, first up, the crux of what's new with Docker 1.12 and later is native clustering. But I'm talking about proper native clustering here. None of what we had in the past with Swarm, where first up we would build a bunch of Docker engines, and then we'd grab Swarm as a separate tool and product and layer it on top. No, absolutely not that anymore. What we're talking about here is proper native clustering. So all built in, proper first-class citizen stuff. And we'll be all over the detail in a second, right? But we're calling this native cluster a swarm. Yeah, obviously it's a cluster of sorts, right? But the folks at Docker Inc. are pushing the term swarm, so I'm happy enough to go with that. A collection of Docker engines joined into a cluster is called a swarm. And then the Docker engines running on each node in the swarm are said to be running in swarm mode. Lingo, lingo, lingo. Now, one of the cool things about this, and it's vitally important as well, is that swarm mode is entirely optional. As we'll see in a second, right, with a single short command, we can put Docker into swarm mode and initialize a new swarm. But we don't have to. And if we don't, well, that's fine. Docker's just going to run like it always has in standalone mode or single engine mode. And in that single engine mode, it is fully backwards compatible. Now let me just repeat that. You do not have to enable swarm mode, and if you don't, then everything's 100% backwards compatible. It just runs like Docker always has. That means if you've got third-party clustering stuff going on, chillax. It's just going to keep working. Anyway, a swarm itself consists of one or more manager nodes, and then one or more worker nodes. As you might expect, the manager nodes look after the state of the cluster and dispatch tasks and the likes to the worker nodes. And managers are highly available, meaning that if one or two or however many of them go away, the ones remaining will keep the swarm going. And it works like this behind the scenes. While you can have X number of managers, an odd number is highly recommended, and only one of them, right, is ever the leader or primary. Yeah, all managers maintain the state of the cluster, but if a manager that's not the leader receives a command, it's going to proxy that command over to the leader, and then the leader's going to action it against the swarm. And you can spread managers across availability zones, regions, data centers, whatever suits your high availability needs. But of course, that's all going to be dependent on the kind of networks that you have. You're going to want reliable networks. Now, I suppose I should mention Raft, because while we can have multiple managers for redundancy and high availability, that naturally gives us complexities over agreeing on the current state, consensus, yeah? Well, Raft is the protocol that's used behind the scenes to bring order to that chaos by ensuring we achieve a distributed consensus. Now, manager nodes are worker nodes as well, so it's totally possible to have a swarm where every node's a manager node. Though more than 5 manager nodes generally isn't thought of as a good idea. The premise here is that the more managers you have, the harder it is to get consensus, or the longer it takes to get consensus. You know what? Just the same way as 2 or 3 people deciding which restaurant to go to is way easier than, 20 people. Anyway, worker nodes, on the other hand, just accept tasks from managers and execute them. Speaking of which, that leads us nicely to services. So, services are also a new concept introduced with swarm mode, meaning if you're not running in swarm mode, then you can't do services. But we're going to be running swarm mode, so a service, right, is a declarative way of running and scaling tasks. I'm sure that's as clear as mud. So, as an example, say you have an app that consists of a back-end store and a front-end web interface. You'd implement that as 2 services, one service for the back-end store and another for the web front-end. Only with services, we tell Docker what we want the app service to look like. And it's now up to Docker to make sure that happens. So let's say we wanted 5 instances of the container that was running the web front-end. You tell Docker that when you define the service. This is an example command here. So it's telling Docker, go create a service called WebFE, and I want 5 instances of the container or task it's going to run. Marvelous. Docker's going to go away and spin up 5 tasks. Think of tasks as containers for now, okay? And it's going to spread them across all the worker nodes in the cluster. Remember, managers are also workers. But here's the thing, right? it is going to make sure that there are always 5 of them running. If one of them dies, there's a reconciliation loop running in the background that'll say, okay, I've got 4 tasks running for this service. Wait up, I should have 5, and it's going to start a new one. And that declarative model of expressing desired state and having Docker keep an eye on things, making sure that actual state always equals desired state, is both new and really powerful. Now, we'll see this in a second, right? But I did mention tasks. So, a task is the atomic unit of work assigned to a worker node. We as developers or sysadmins or whatever tell the manager about services, then the manager assigns the work of that service out to worker nodes as tasks. Now, right now, tasks means containers. Okay, a little bit more, so they include metadata about how to initiate the container and some runtime stuff, right? But we can pretty much think of a task as being a container. But, and this is crystal ball time here, right? There's actually nothing technically stopping tasks including other things like unikernels or any other unit of work in the future. It's just right now, tasks mean containers. Anyway, we've got a swarm consisting of a bunch of manager nodes and worker nodes. We define services, declare them to the manager via the standard Docker API, albeit new endpoints in the API. The manager then splits the service into tasks and schedules those tasks against available nodes in the swarm. And then, in order to deploy complex apps consisting of multiple distributed independently scalable services, we've got stacks and distributed application bundles. And there's more, right? And we'll see a bunch of it really, really soon if I stop waffling. But yeah, I reckon we've got enough to get started. So let's go build a swarm.